divide and conquer in this session. We have already studied the dynamic programming in the last session. Okay, so let's first discuss why divide and conquer. What is the need of this algorithm, divide and conquer? Let's say that there is some. Let's say you have to perform some operations, and you have given with a problem, and you know that the problem consists of some sub problems, and you know that the way I'm solving the main problem, I can solve the sub problems as well. So if the sub problem is being solved, I'll be able to solve that problem very easily. Okay. So in this case, how we are going to approach these? Let's say in the case of dynamic programming, what we are doing, we are dividing our main problem into sub problems, and what we are doing after solving that sub problem, we are storing that value of that sub problem in some memory, and if anywhere else in the program, if we need that value or that value in somewhere else in the program. So what we are doing, we are using that value. But in the divide and conquer case, what we'll be doing will be not storing the values somewhere. It means in the divide and conquer, will not be solving the sub problems again and again, because all the sub problems will be different, and there is no need of storing that value of that sub problem. Okay, so let's say, okay, let's take an example of divide and conquer algorithm. Let's say the first, okay, the first and very easy example I'll be taking, that is binary tree. Oh, sorry, binary search. Let's say binary search. Okay, so we all know what binary search is. Let's say you have given with some numbers. That number should be sorted. We all know that for applying a binary search algorithm, the number should be in the sorted order. Okay, let's say 7, 8, 10, 15, 19, and 20 is given with us. And what I need to search, let's say, I need to search 7 into it. Okay, I need to search 7. So what I'll be doing, let's say in this, let's say it is an array that has been given with us, and what we need, I need to search 7. If search is 7 exists in my array, it should return the index of that position, or if it does not exist, what it should return, it should return this any value, let's say -1. Okay, so let's say what we'll be doing in the case of binary search, first we'll be finding the mid index. Of course, in this case, it will be the 15, and we'll compare 7 with 15. If 7 is greater than 15 or lesser than 15, 7 is of course lesser than 15. Then we know that the solution, if it exists, it will exist in this case, not in this case. Okay, it means here we have divided our problem. It means we have divided our problem, and we know now in this part this the 7 will not exist, because we all know this is an sorted array. So for doing that, it means we are dividing our array. So it comes under divide and conquer. First we are dividing it, and then after we are solving it. Let's say again, we all know that it will exist into this array, this sub problem, this sub array. So again I'll divide it with 7 with mid element. Let's say right now mid element is 7, 8, and I'll compare 7 with 8. 7 is lesser than 8, so it will, if it exists, it will exist at the left side of the 8, not the right side of the 8. Okay. Again, in the next time, 7 is equal to 7. It means I'll return the index of this position. Okay. So basically, if I talk about the divide and conquer, it means simply dividing your main problem into sub problems. It means that it says that you can solve, if you can solve a sub problem quickly, you divide that problem, you perform your task, and you can let's say combine those problems, combine the solution again. So in the case of dynamic programming, we are doing in the same way, but what we have seen, let's say dynamic programming is it's the best form of this. If let's say there could be a problem, there's a problem exists, it has the sub problems, it has already the sub problems, but those sub problems are the common. Let's say this has a common sub problem. In that case, what we can do, we can store the value. But here we are seeing that will not be getting anything common, any common subproblem. So we cannot apply dynamic programming here. So yes, we can apply the divide and conquer, and of course for dividing, we all know if we can solve a sub problem. So for doing that, I'll be using recursion, simple recursion. Okay, let's say if I'm let's say because we have already discussed the binary search in the very beginning of this course, so then I think we have discussed it with the help of iteration. Okay, let's quickly do it with the help of recursion. How we can solve the binary search, how we can apply the binary search with the help of recursion. Okay, let's say we are given with an array and the size of that array is n. Let's ask our user to enter the size of that array. Let's say I'm asking c in, yes, okay, same n. Okay, and yes, you can use last time we have used array. Now I'm going to use vector. You can use array or vector, anything, it does not matter. So I'm saying that's the name of that vector is b, and let's run a for loop int I is equal to 0, I is less than n, I plus plus int a in a. I'm just taking the input from the user and pushing it back into my vector. We dot push back to my vector. Okay. So now what I'll be doing, I'll be taking another input from the user. Okay. So what the user wants to search into the given array. Let's say for doing that, what I'll be creating a binary search function. Binary search function. I'll be passing my vector through it as well as my starting position, my ending index that will be n minus 1 of course, and the k that you need to search in that vector. Okay. So for doing that, what I can do, let's quickly include or with slash library because we are using vector here. Okay. So for doing that, what I can do, I can create my binary search function. Because why this return type is integer, because it will return the index. If it found that value present in that array or in that vector, it will return the index of that value. Or if it does not find that value, it will return -1. Let's say -1, -2, you can write anything. Okay. So what I'll be writing here, vector of int, let's name it p, int start because it will be the start point, int end. Okay, int k. Why I'm writing int start and end? Let's say because we have already discussed in this case. Okay, let's say here I want to search, let's say 7. So what I'll be doing, I'll be passing my start from 7 and end for end index as 20. And what I'll be calculating, I'll be calculating the mid of that 7 and 20. The index of 7 is 0 and it is -1, so I'll be getting the index of 15 as the middle element. So I'll compare 15 and 7. If 7 is less than, if both are equal, I'll return the index of mid. If they both are not equal, either it will be lesser than 15, either it will be greater than 15. If it is lesser than 15, I'll be calling that function again, starting from start as well as mid -1 because it is the mid. And if it is greater than that, it means it exists at the right position. So I'll be calling my function again, that from mid +1 to end. Okay, I hope it is fine because I think you have already did that this code. So when I'll be knowing that the value does not exist in my array, let's say here what I'm doing, let's say I'm searching it for 71. Okay, so 15 will be compared with 71. So it will say that 71 will exist after that 15. So 19 and 20, the start will be this now, and the 20 will be this now. Let's say this is start, this is the end now. Okay, so after start and end, let's say 0, 1, 2, 3, 4. The index of this is 4 and 5. Okay, So 4 plus 5 divided by 2, it is 4. So index, the middle element will be 19 again. So 19 will be compared with the 17. So it will say that yes, the 71 is greater than 19. So it will say that it is the middle element now. So it will say that it exists at my right side. So the middle plus one, that will be end in the start as well as in the end. The both value will be 5. Now start and end both is 5. Again it will go to that. It will compare that 71 with start and end. Of course 5 plus 5 divided by 2 is 5 itself. So it will compare 20 with it. So 71 will be greater than that value. Okay. So it will say that you call this function for mid plus 1 and the end. So mid plus 1 is now mid, start will be mid plus 1, mid is right now 5, and 5 plus 1, that is 6. So now start becomes our 6 and end is 5 now. So if start is going after the end, it means that we cannot do that. It means that we have already checked the values between these two, and we know that the value does not exist in our array or in our vector. So what I'll be doing, if start becomes greater than end, return -1. Okay. Else calculate int mid is equal to start plus end by 2. Okay. What I'll be doing, I'll be first checking if b of mid equal to k. If you found that mid value is equal to k, you return that mid. Okay. If it is not the case, it means either it will be the smaller than that value or it will be the greater than. If b of mid is greater than k, it means k is the smaller than that. It means it will be lying in the left part. So I'll be calling my binary search again, and I'll be saying that binary search pass my vector through it, and I know that it will lie to the left part. So I'll be calling my function start and mid -1, because it will start from start and mid -1. The value will exist in between start and mid -1 because it is lesser than that mid. Okay. And of course we know it is not equal to mid. That's why the function is coming here. So for the value that this function is going to return, I'm going to return as it is. Okay. If it is the mid is not greater than k, it means it will come here. Either you can make a condition or you can directly write that if mid is if that k is greater than this b of mid. In that case only it will come to line number 23. I can directly write binary search. It means that my value will exist at the right part. So it will, the start will be mid plus 1 and the end will be end itself. Okay. And I'll passing my key. Let's see whether we are getting the correct output or not. Let's say 5, 1, 2, 3, 4, 5. Okay. Let's say I want to search 2. I should be getting the index as 1. Let's see whether we are getting the correct output or not. Okay. So it is saying, okay, we have written the spelling of the vector is wrong. It is vector anywhere. Vector is 5. Okay, let's quickly run it. Okay, we are getting the output as 1. Let's try to search 6. That is not there in our array, so I should be getting -1. If we are getting the -1, it means we have done it right. Okay, we are getting the -1. Let's try to search 61. We are getting the -1 again. I should be getting -1. Okay, 5. Let's try to search 4. 5. The index of 5 should be 4 because its index is starting from 0 to 4. Okay. So I hope you got the binary search with the help of recursion. Or do anybody is having any doubt in this code? Or you want to take some time, you can take. Or if you have not got the problem, or if you have any problem, if you are facing any type kind of issue, you can write on the group chat. Or if it is clear, I can move to the another problem of divide and conquer. This is a very basic problem of divide and conquer. So if it is clear, we can move to the quick sort. Yes, quick sort is also a very famous problem of the divide and conquer. Is it clear, everyone? Okay, could you visualize how we are getting -1? Okay, how we are getting -1? Let's say, okay, let's say I'm giving the input as 51. Okay, let's visualize it. Let's try run how we are getting the minus. Okay, again, let's say the array is something like this: 1, 2, 3, 4, 5. Okay, 1, 2, 3, 4, and 5. It is starting from 0. It is going to 1, 2, 3, 4. Okay, this is 1, 2, 3, 4, and 5. Okay, so let's say I want to search 51 into it. So right now my vector is looking like something this, and my start is 0 and end is 4, because started right now start is 0 and end is 4. Okay, let's say this is the end. Okay, so what it is saying, if start is greater than end, right now start is lesser than end, 0 is of course less than 4, so it will not pass this condition. So it is going to say that mid is going to start plus end divided by 2. 0 plus 4 divided by 2 is 2. So it will come to this index, that is 2. Okay, the mid is now 2. The mid is now 2. So now it is saying, if b of mid is equal to k, k is right now 51 and b of mid is not equal to k, so 3 is not equal to 51. So it will say that if b of mid is greater than k, b of mid, that is 3, is greater than 51. No, it is not greater than 51. So it is going to say return what is the function, what is this function is going to return, use same the value. So it is going to call this function and it is going to ask the solution of this function to this function call. Okay, now it is saying that call binary search again and pass this b and mid. Now right now in the start, pass now start is equal to, now our updated start is equal to mid plus 1. Mid is right now 2. It is the right now the start is 3, because mid plus 1 is 3 and end itself, end is 4. Okay, okay, Pandit Singh, you got it. Okay, let me complete it if you have started something. Okay, so 3 and 4. Now again it will compare 3 and 4, because it will go onto the right side again and keep on going on the right side. If the start becomes greater than the end, it will return that -1. Okay, so in that case we are getting the -1. Okay, okay,